Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Fred Schenkelberg. Hey, Carl.
Hey, Fred.
Hey, I understand you got a planning a trip, a kayaking trip. Is this like a 3-week trek around the...
No, this is a day trip. Too easy.
Okay. All right. Just getting out and enjoying the springtime, and that's all good.
Yes, exactly. Do it in the morning before it gets too hot here because we're in Florida.
Oh, okay.
And, but we want to get out amongst the mangroves, which is really fun for kayaking.
Oh, that'd be cool. Right? Can you harvest mangroves, or is that just a tree?
I suppose you could. I think it's illegal, frankly.
Okay. That might be frowned on then. Yeah. Come back with a big pile of harvested trees.
Hey, Fred, I was thinking about a topic to talk about is actually reflecting on this even before thinking about podcasting.
Mm-hmm.
It's and the topic is the most common reliability mistakes.
Oh, nobody listening to this show makes any mistakes.
And of course, we never made any, so we have to invent some.
Yeah, you're right. Just mentioning that topic, I'm thinking of about a dozen even an email last week was just, I don't want to spin out of control on it because I could. It obviously has something to do with MTBF, but they were asking a question about how do you derive the formula for a confidence interval on something? And it became quite clear there wasn't a whole lot of depth of knowledge about statistics in general. And it's like, well, I'm not sure how to answer that question. And it says, by the way, don't use MTBF. It's really not very useful. And it came back with a rebuttal to that, which I thought was interesting. And it was, well, we took some of our field data and I analyzed it with a Weibull distribution, and it said that over the 2-year period, we have an 80% or 90%. I don't remember what the numbers were, but we have a 90% reliability over 2 years. But when I just tallied up the time and divided by the failures to estimate MTBF or MTTF, I got a 98% reliability, which is much better.
Huh. Well, there you go.
Yeah. And so we're going to use that. It's easy to use. I don't need a computer and I get a better number. And, I wrote back, well, better for what you want, independent of whether it reflects reality, is the problem. So if you're going to use that logic, why do any calculation whatsoever and just pick whatever number out of the air you want? And I was like, so the underlying mistake was not understanding how do you, interpret data that you've got in front of you is understanding that data and understanding if it's a good fit or not, if you're doing a regression analysis, which I don't really even got the impression that this person understood they were doing that. And I was like, oh, I don't even know where to start with that mistake.
Exactly. But any one person may not have the knowledge to interpret the data.
Yeah.
The underlying error is not knowing that you don't know. Because if there's a body of knowledge I don't know, and I know that I don't know, I'm going to look for somebody to help out.
Yeah.
I'm going to consult a friend. I'm going to,
I'm going to get on Google. It's a short thing is, how do I do this properly? Or, or walk down the hall and say, boss, is this the right way to approach this problem? Or something. Yeah.
But if you don't know that you don't know something, there's a humility involved here, and you think you know it and you don't. That's a really dangerous assumption.
Yep.
And then you're going to make those kind of mistakes like your friend made or the person you're talking about.
Right.
I had on the same thread, and then I know we can move away from the that type of mistake, but one just came to mind is I was with a company consulting and on reliability, and they had a product that had a target life of 10 years, and it was expected to last 10 years, but it was a very expensive product. So they decided to test it for one equivalent of 1 year.
Okay.
And just assume that it would be the same failure rate over 10 years. And so they based their entire program on that. And of course, they had all kinds of problems after 1 year. So it's the same.
It's the same nature one, but it's ignoring the assumptions. And I think I mentioned it in one of the recent recordings. I've done a bunch of recording this week. Is I really appreciated Wayne Nelson's book, Accelerated Testing, which is one of the very first books I picked up in the reliability field, in reliability statistics. And each of the approaches to doing accelerated life data analysis included, a short introduction in the next section is the important assumptions.
Oh, that's fantastic.
And it included, how do you test them? And how do you tell if it's independent, or how do you tell if it's this, or how do you tell if it's that? And that stuck with me forever. Yet I agree with you. It's very, very common with people. Well, we're only interested in the flat part of the curve, so we're going to assume it's a constant hazard rate for everything. And it's an easy trap to get into.
Easy trap. And in Wayne's effort to surface the underlying assumption and make sure it's at least recognized, then can be tested, that type of thought process is really important in reliability. And no matter what you're doing, you should always know what assumptions you're using.
Well, that's related to it came out of a computer, it must be right. And
there you go.
I saw one of them. We'll have to move off of regression analysis here pretty quick, because there's lots of examples of that.
Yes, exactly.
I was in a legal case, and I'm asked to look over some of the data and how they're analyzing it. And I was like, you've got to be kidding me. They used a 3-parameter Weibull, and the third parameter is rarely used unless you have a known period where your product just isn't possible for it to fail. Say it's in shipment or it's in storage and something like that. And it's some finite amount of time, and then it gets put on the shelf and so on and used. But they had a negative number there, and it was a minus 3 months that it was not possible for it to fail. And the product hadn't even been built yet. And if you took that out and you analyzed the data without that factor in it, they got a very different answer, and it predicted much worse failure rates, or it revealed that the data actually fit a 2-parameter fairly well. And yet the ending result was that their mistake was that they picked a number that showed that it was better than it was. And I was like, just because, and this is one where the automatic computer wizards was the technique they were using, and it would check, a dozen different distributions as well. Given this data, this is the best fit, independent of actual reality. And so the mistake was not thinking through, is this even possible? Does this make any sense?
Right.
My boss used to call it the sniff test. He goes, this doesn't smell right here. We need to fix this.
I remember making that mistake very early. In fact, I made the mistake in a final exam once in my undergraduate degree.
And they let you graduate?
I went through, the final exam was one problem. And I went through the entire problem and got to the end of it, and then ended up with they were designing a gear for a mixer, like a little cake mixer.
Okay.
And right at the end, I got the diameter of the gear was like 24 inches or something.
Ooh, that's a big mixer.
It just did not make any sense, of course, but I didn't catch that in time.
Well, I did that with in physics. We often had to tell if it was, what direction was the current flowing type thing. And there was this right hand technique where if you put your hand straight out in the direction of, say, the wire, and you curl your hand, that's the field going around the wire, and the current flow is the direction of your thumb. And so you could get this, you had this little way of getting the direction correct. You had the sign was part of that, right? So I'm in the test and I'm doing that, and I'm using my left hand to do that mechanism. So it's 180 out. And I didn't recognize it until the end of it, and I had no more time left. I'm like, oops.
Whoops. Yeah, I mean, a real easy one that's on the same common sense thread is the reliability of 97.99 something or other.
Mm-hmm.
Too many decimal points. That's a tell that someone's got a wrong assumption going somewhere. I have one that's a higher. If you go up 30,000 feet,
Yeah.
And it's one of the ones I thought about this morning as I was musing about reliability. And it's not having a plan. And I've seen that so many times where people will get on a new job. I'm now the reliability person, and they're going about trying to firefight or whatever they're doing, or they're going to implement reliability on a new program, but they don't create a plan. They don't have a step-by-step of how you get from where you are to where you need to be. It's like the recognition that you need a plan instead of just going about your work.
Well, if you're a mechanical engineer, you have an objective, right? We need to make a gear, and hopefully not 24 inches. But yeah, may have an informal plan. Well, I'm going to use my CAD program, and we have milestones, and we're going to make prototypes and stuff like that. And there's usually a project manager or program manager that imposes a plan, essentially, for new product development, for example, or installing a new piece of equipment. And I've run into where reliability folks will say, well, the project plan doesn't want the extra line of the reliability thing, so I'm just going to go about doing stuff.
Yeah.
So it's a common mistake. I agree. Yet I think that takes a bit of experience to realize that if separating getting the product out on time or improving field failure, reducing field failure rates and stuff like that, those things are urgent a lot of times. Oh, we need this test data by the end of the month, or we need this, and yet recognizing that that's not coherent and it's not actually focusing on what's the most important things to do and moving the program forward, that takes a bit more time to sort out, I think. It
does. I was fortunate early in my career to go to training that had Stephen Covey material. And so I can visualize the matrix of important, not important, urgent, not urgent.
Yep.
And somehow it became important to me, using
no
that
pun
word,
intended, to be in the important square.
To work on important things, because all I saw was everybody around me working on urgent things, and the important things don't get done.
Yeah, until they become urgent.
Bothered the heck out of me.
Yeah.
Yeah. And so I now visualize that matrix on almost any conversation. And it's the reason, not just the Stephen Covey, but it's the reason we wrote our book.
Yeah.
It's how do you achieve high reliability? You don't achieve it just by going for that last result.
Yeah, that brings up another concept is, our reliability plan is that we're going to throw a couple units in the chamber and see if they work. It's kind of, we'll test it in at the end of the line, but then we don't have any time to change anything. So it's, we don't spend a lot of money on it because we're not going to do anything with it anyway. It's just in case if anything's major problem. And
wow, that misses so many steps.
Well, it does. I'm sure you've run into this as well. We don't have time to design in reliability. We'll throw a couple in the chamber later, see if anything's a problem. And then, the next sentence is, well, we're launching next week, so we can't redesign it now. And
right.
We'll make it up later,
They painted themselves into a corner.
Yeah. And that's part of that, not having a plan. Yet it's for a brand new concept startup, I have run into the spectrum of that where one company was, if we get one chance to do this and get market acceptance, and reliability is a clear requirement, and they doubled down on that. And I just saw a note from them the other day. They're doing EV charger stations, and so they're just going gangbuster. They were a bit of timing on that helped, but they actually made a unit that is more reliable than their competitors, and so they're in a really good spot. Can't make enough of them. Whereas other group was, well, if the customer does that and it breaks, well, it's their fault. So, but that'll never happen. This thing's expensive. They'll have to take care of it. And it was this unstable glass cylinder that wasn't attached to the basin in any coherent way. So that if you bump the table just slightly, the thing would wobble and fall over and crash. And it was the most expensive part of their product. And they dismissed it as, well, that's the customer's fault. And,
oh, no.
And they're not in business anymore.
I'm sorry. That would be a huge mistake. And so let's add that to the list of common mistakes, is blaming it on the customer.
Well, it kind of goes hand in hand. When I see a really large number of no trouble found, it's just putting mufflers on your ears of deliberately not listening to your customers. They're sending it back to you. That is not a trivial action. And it's costing you money. And if you choose to ignore it, that's a mistake.
Oh, yeah, exactly. So I'm going to toggle, because I had a realization here, a little light bulb turned on. Mm-hmm. So I'm going to toggle between not having a plan and another common mistake, and I'm going to call it being a one-trick pony. And that's where, I use HALT everywhere. I use FMEA everywhere. I use Taguchi methods everywhere. You have some hobby horse that is your plan, not your plan. I'm sorry, your tool.
Yeah, you always use that tool, no matter what.
No matter what. So we're going to throw it in the chamber, whatever, and that's the way you achieve reliability. So I'm going to toggle between those, because I think a one-trick pony is a mistake. For some people, it's a habit. They've had success at it. Maybe they've been acclaimed as really good. And yet that's a mistake. And I'm thinking now, and I just had a realization that having a plan, a rigorous step-by-step plan, doesn't have to be that rigorous, but at least
coherent.
Coherent.
Supportable.
At least compensate for the error of having a hobby horse.
Yeah. Because
you can't use FMEA as your only tool if you do the planning like it's in our book.
Yeah.
You just can't do it. And so it compensates.
Well, there's always a bias, and we recognize that we know all the good ways this works. We don't really understand these other tools, so we'll tend to pick our favorite tools. I don't think it's easier to justify the ones that you're familiar with, and that's a bias. I think the mistake goes back to one of our first ones, is that you need to understand the other tools deliberately so that you can make a good decision of which one is the appropriate approach or tool for your current situation. And I think that's what leads to the hobby horse one as well. It worked really great last program, and I'm really familiar with it now. And this is kind of like that. It's close enough. You've seen it in project management, it's like, well, this project's not a big change, so we're going to streamline everything and do the minimum, and reliability often gets put aside, and it's like, you had to talk yourself into this, that it's not a big deal. And that's part of that bias showing the same kind of phenomena, I think.
Well, yeah, I think that's well stated. I can't tell you how many people I run into at conferences, like I'll just think of RAMs, but of course I've spent years at applied reliability symposiums, and just talking with people over lunch or dinner or in between sessions. And I get the idea from talking with them that they're going about their reliability business using a specific tool primarily.
Yep.
And in the back of my mind is going, why don't you use a plan? Why don't you develop a plan? And it just hit me here again. So with this good podcast, because I'm having some realizations. People tend to stay within their comfort zone.
Oh, yeah. Yeah. There's part of it was when I really got enmeshed into doing reliability type stuff. At first it was because there were specific problems that needed solving. So I was like, oh, can I design this and run and analyze an accelerated degradation test? And it was very specific tools. Yet that tool, I ended up getting recognized as somebody that knew how to do accelerated testing and the statistics involved with it. And I could have stayed with that. I could have done nothing but accelerated testing and been that person that got real deep into that expertise. And there's people that are really, really good at design of experiments, and every problem they run into, it's, well, we got to do a design of experiments, and they can tailor it to that particular thing. And same with FMEA and everything else. There are domain experts that you would call because you want to use that well, and you go get them to do it. I mean, we both know people that everything is halt. That's the only thing you need to do during development. And I think I finally have convinced Kirk that it's not the only tool. I think he actually admitted to doing some statistics once, but I'll just pick on him a little bit. But there's a place for both the deep expertise in a particular method and being very good at applying it. If, and this is a mistake I see, is if they recognize that, well, in this circumstance, this isn't the right tool, and you need to approach it a different way. It's not my expertise, but good luck. Have a good time. As opposed to the mistake the experts make going, oh, we can always shoehorn this in here. You want to do fracas using an FMEA chart? Sure, we'll stick it in there.
Yeah, we'll
we'll add a column.
Well, and you and I talked about this when in our book, we have this appendix, and which is still it's an accessible document.
Yep.
But the appendix would be the different tools.
Yep.
And we understand the importance of knowing the limitations. So it isn't just a matter of knowing what the tool is and what it does. It's a matter for every tool. You have to understand the limitations of it. Yep. And that's not well understood by a lot of people. They just get, here's the tool, this is what it does, it's good at this, but it's also not good at this and this.
Yeah. And I think part of that, why we listed, I don't know, it's close to 100 tools or methods, I think we call them, is just to raise awareness that, if you happen to be like I was, only did a couple of accelerated tests, and I thought, well, okay, that's reliability. Wait a sec, there's field data analysis, there's failure analysis, there's all these other activities that I wasn't aware of. And it wasn't until I started poking around and talking to lots of other organizations and stuff like that I got familiar with so many different techniques and tools and so on. I was in a unique position to do that. But it is important. Otherwise, it goes back to that one trick pony kind of thing, or that's we're doing reliability, and you've seen them as they're doing parts count prediction. And I think that's all you need to do.
Well, yeah, that's right. Oh boy, so many stories. I'll just share one story, and then we can consult with our listeners on what they think are common mistakes.
Yeah.
But a very short story is sort of midway in my General Motors career. One of the quality people invited Junichi Taguchi to GM, and he's like the father. He's the discoverer of Taguchi methods, of course. And it was a nice lecture, but it was dry, kind of difficult for people to understand because he filled up an auditorium of people, and he's going over the techniques of the analysis, which can get very technical. And at the end of it, one of the managers wrote to our engineering group, says, okay, this is great methods, we're going to use it. So he mandated that for every program, we'd be using Taguchi methods all the time. Basically, that's a key part of the program. So he was trying to implement a hobby. And just because it looked so good he was basically convinced. So that would be an example of the wrong thing to do. You would pick a Taguchi method only if it is part of your overall reliability program, not because some manager decides to mandate
it. Yeah, and I've seen that way too many times. Mandate this kind of testing or this kind of activity or this kind of protocol or whatever is you will do it this way. And you see it in military contracts. Thou shalt do an FMEA from off the bill of material. And nobody ever reads it.
Not only going to do an FMEA, you're going to do a quantitative criticality analysis, which is, not often needed.
Yeah. And it's just But there's so many of them. We could go on and on. This one.
There's like an unending series of stories that are coming to mind.
Yep.
I want to see if our listeners, if you're listening to this podcast and have any common mistakes that you're aware of, that you'd like to call to our attention, I'd love to hear from you. We might podcast about it because, like I said, and I'm sure Fred agrees, there's so many different mistakes that we could cover a podcast series on this one.
Oh, yeah.
Love to hear from you.
Yeah. And I mean, we're certainly just scratching the surface on this one, but let us know what's your favorite one. And I think more importantly is one of the things we didn't do all that well here, Carl, is, well, what do you do about it? If you recognize this mistake is happening, what do you do about it? I think having a plan is a great step for many of the types of mistakes we have mentioned, yet there's others. There's plenty of others. Some are more cultural based and so on. So let us know. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Carl and I and the other hosts are available through LinkedIn and our About pages. So there's plenty of ways for you to share your insights around these common mistakes that abound in not only our industry, and plenty of other walks of life too. But we're interested in exposing these so that we can critically take a look at it and say, yep, that's what we need to do, or no, hey, let's look at this a different way.
Great.
Oh, I'm just biting my tongue here because I got like 15 more I'm going to go.
I know. Well, I'm going to try to go the rest of my day without making any common reliability mistakes.
There you go. Good luck with that. Yep. Especially if you're in a mangrove grove on your kayak, that might be a good place not to have a reliability problem.
Indeed.
All right. Well, good talking to you, Carl. Talk to you soon.
Talk to you soon, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.